Section 12.3 is on surface areas of pyramids and cones. A pyramid is a polyhedron that is a three-dimensional shape with flat surfaces with a polygonal base, that is, the base of it is a polygon, and three or more triangular faces that meet at a common vertex. It's called a regular pyramid if the base is a regular polygon. Here's a sketch of one. So here we have a, could be a square-based or a rectangular-based pyramid. The four faces are the four triangles that meet at the top at the vertex. The height is the distance from the vertex to the base, and remember, distance has to be perpendicular, so whatever that is. The slant height is the height of one of the lateral faces. So if you were just looking at this one triangle on the side, what is the height of that triangle? From the top of the triangle, perpendicular to the base, what is the length of that segment? So to find the lateral area of a pyramid, we use the formula L equals 1/2 PL, where P is the perimeter of the base and lowercase l is the slant height. So we use a capital printed L for the lateral area and a lowercase l for the slant height. So 1/2 perimeter times slant height. The total surface area of a pyramid is given by the formula S equals 1/2 PL plus B. Notice 1/2 PL is the lateral area plus B, capital B, where B is the area of the base. And you can have pyramids with all sorts of different polygons as bases, so that's why it's generic and it's just a B. So here's our first example. Let's find the lateral area and the surface area of this regular pyramid. Well, since this is a regular pyramid, the base of this is going to be a regular square. Sometimes I like to draw the base separately. So my base, since I know it has four sides, and since it is regular, it's going to be a square. So that's 12 centimeters, and that's 12 centimeters. So the two things that I need to know about this is, first of all, I need to know the perimeter of my base. So that's going to be 4 times 12, which is 48. The other thing I'm going to need to know is what's the area of the base. Remember, area of the base is capital B, and that's going to be 12 times 12, or 144. The other thing I need to find is what is the slant height. Okay, notice I have the height represented by this blue line, okay, and then I have the slant height represented by this pink dashed line. Something that's really helpful is to draw the triangle on the inside. So here's that triangle. So I have, that's my height, which is given by 16. I have my slant height, which I don't know what it is, I'll call that L. And then I have this distance across the bottom represented by this green dashed line. And since this is a regular pyramid, this point right here is going to be the center of the square. So if that's this point right here, then that green dashed line, that's going to be 6. So on my triangle on the inside, I have a right triangle that has a height of 12, a base of 6, and the slant height is going to be the hypotenuse. So I'll use the Pythagorean theorem to figure that out. So L is approximately equal to 17.1. So now I think I have all of the players that I need for my lateral area and surface area. L equals 1/2 PL, or 1/2. My perimeter is a 48, and my slant height is 17.1, and that gives me approximately 410.4 centimeters squared. That's my lateral area, so that's the area of all four of those triangles. And then my total surface area is going to be 1/2 perimeter times slant height plus the area of the base. so 410.4 plus the area of the base, which was 144, or 554.4 square centimeters. One thing that can be really helpful in doing one of these is to draw your base in 2 dimensions so you can see what the perimeter is, what the area is, and then if necessary draw this triangle on the inside. Draw that in 2 dimensions so that you can find any missing lengths that you need. Now a cone is a solid that has a circular base connected by a curved surface with a single vertex. So just think of an ice cream cone upside down. So here we have our circular base, and the pink dashed line is the radius of the base. The blue dashed line is the height, that's the distance from the vertex perpendicular to the base, and then the length of the edge from the vertex to the outside edge of the circle, that's your slant height. And the formulas for lateral area and surface area: lateral area is given by L equals pi times R times L, pi times the radius of the base times the slant height. So that's going to be that cone-shaped part. And then the total surface area is given by S equals pi RL plus pi R squared, or the lateral area plus the area of the circular base. So let's take a look at an example. Find the lateral area and the surface area of this cone. So I know that, taking a look at this, the diameter of the base is 15, so that means my radius is going to be 7.5. My height, if I need it, is 15, and my slant height is what I don't know. So in order to figure this one out, I'm going to need the slant height. So again, I'm going to have to draw the triangle on the inside. I'll do it over here. This just helps me to see it a little bit better. So there's my height, which is 15. There's from the center to the outside edge of the cone, so that's this distance here, which is going to be 7.5. And then what I don't know is my slant height. So again, using the Pythagorean theorem, 7.5 squared plus 15 squared equals my slant height squared. So L is approximately equal to 16.8. And now I think I have all of the numbers that I'm going to need. So my lateral area is pi times the radius times the slant height, or pi times 7.5 times 16.8, or approximately equal to 395.8 centimeters squared. And then my total surface area is going to take my slant height and add to that the area of the circular base, or 395.8 plus pi times 7.5 squared, which gives me approximately 572.5 square centimeters. So in order to find the surface area and the lateral area, of pyramids and cones, make sure you're familiar with those formulas. Again, you don't have to have them memorized. And remember, sometimes it's really helpful to go ahead and draw the triangle on the inside of the pyramid or cone, and if necessary, draw the base as well.